All right, welcome back to Mr. P. Helps with Algebra 2. This is Unit 3, Topic 1, SLT number 1, and we're starting our trigonometry, and we're going to, in this video, find the various heights of different points on a Ferris wheel, which we have to use our trigonometry in order to figure out the height of that spot. In order to do that, we're going to have to do a skill like this, which you should have already done in geometry, which is using the SOHCAHTOA, which stands for sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is always opposite over adjacent. So in this case, I have this given angle, I have this given side. Now this is the hypotenuse, because a hypotenuse is always the longest side. It's also always across from the right angle. And I want to know the opposite side. I want to know the side that is across from the angle that I know. Adjacent would be next to, so this would have been the adjacent side. Since I want to find the opposite side and I know the hypotenuse side, the trig function I'm going to use is sine. So I'm going to do sine of 32 is equal to opposite over hypotenuse. If I want to find x, well, I'm going to do the inverse operation, which is multiply both sides by 18, so that cancels these out. So then I have my answer. All I have to do is use my graphing calculator, put in 18 times sine of 32. Also, before you do anything else, you want to check to make sure that your calculator is in degrees by going to mode and then moving over to degrees. I believe radians is actually what it usually is on, so you do have to change it normally. So once again, so that's 18 times sine of 32, enter, and that gives you 9.54 rounded to the nearest hundredth. This one over here, I have this angle, so that's my angle given. I know the hypotenuse, and I want to find the opposite side, which means I'm once again going to use sine. Sine of 59 is equal to opposite over hypotenuse. Multiply both sides by 28. These cancel, and that's how you get your answer. 28 times sine of 59, which is about exactly 24, is our answer. All right, so that kind of gives you a little idea of what we're going to be doing in this video. Let me just move myself to a better place. So we have this Ferris wheel. We want to find out what's the heights, because Carlos is afraid of heights, and he wants to know what's the heights at all of these positions. Now, they tell you a little bit of information about the Ferris wheel. So he finds out that the radius is 25. So the distance from here to here is 25. And since it's a circle, we know that the distance of the radius is going to be the same going in any direction. We also know that the center is 30 feet high. So that alone, that information gives us actually two of the answers, I should say. So how high will he be at the highest point? Well, if it's 30 feet high here plus another 25 feet here, which 30 plus 25 simply is 55 feet. How high will he be at the bottom? Well, if it's 30 feet to get to this point, and then you go back down 25 feet, so 30 minus 25 equals 5 feet high. So this point's only 5 feet high. This point would be 55 feet high. But those are not two of the locations that we are looking for. How high will he be if he is at the position on the far right or the far left? Well, that's position A and position F. He'll be 30 feet high because position A is the same height as the center height, and position F is also the same height as position A. All right, so same question. Since Ferris wheel has 10 spokes, Carlos wants to know how high he'll be at each position. Well, if it has 10 spokes going all the way around, and we know a circle is 360 degrees, which means that we know that 360 degrees divided by 10 different spokes, because there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 different pie pieces, if you want to look at it that way. That means that each one is going to be 36 degrees. All right, so we already found points A and F. How high are they off the ground? So we already said, no, I forgot the number. It was 30, I believe. So it's 30. They were the same measure. If they're another point that will be the same distance from the ground as point B. Yes, B and E are the same distance to the ground. Well, if I make this into a right triangle like this, and I make this right triangle over here, then position B and E will be the exact same height, because this height and this height will be exactly the same. Position C is the same as position D, G is the same as J, and H is the same as I. So we know that they all kind of line up. Now, I kind of got ahead of myself telling you that this is already 36 degrees, which I believe is a part of the questions in here. So how are we going to find this height? Well, we know that this point right here on spoke A is the same height as spoke A, so we know that has a height of 30. If we can add that to the height of this triangle, then we would know the height of B. And if we know the height of B, then we would also know the height of E, because they would have to be exactly the same. So we're just going to put an X right here because we don't know the height of this triangle. But like we did on the warm-up, we can figure it out. We can do sine of 36 because that's how many degrees there are in each, and that's this question here, but I already did it. And is equal to opposite over hypotenuse, which means I'm just going to multiply 25 times sine of 36, which gives me 14.69. 14.69, which means that this height is 14.69. Now, if I take that 14.69 and I add it to the height, remember, of that sprocket that I already mentioned, and that gives you 44.69. So that's the height of B. Now, therefore, the height of E is also 44.69 because these two have to have the exact same heights. Now, if I wanted to find position C, I would do the exact same thing. And you know what? To make this video as short as possible, I'm going to just go ahead and describe, so I can just stop on the next slide, the way I would find J and G, because this is 36 degrees and this is also 36 degrees. So if this is 14.69, then you know that this height is also 14.69 of this triangle, which means you're going to do 30 minus 14.69, and that gives you a height of 15.31. Now, when I do this next one, when I find the height of position C, I will do the exact same thing, and whatever this height is, I would add it to find the height of C to 30, and I would subtract it from 30 to get the height of point I. And whatever I is, of course, then you know H is going to be the same. So really what you'll notice is to figure out the positions of all of the points, you only need the heights of two triangles. You need to know the height of this triangle right here, which is the same as this triangle. It doesn't matter which one it is. And you need to know the height of this triangle right here, which is the same as this triangle. It's also the same as this triangle. So there's really only two different triangles, even though there are, I believe, let's see, 8 triangles altogether. There's 4 of these tall ones and then 4 of these shorter ones. But really, there's only 2 different triangles being created. So you can find a position of all, you can find the height of all the other positions if you just do those 2 solving for those 2 positions. So here we go. So this triangle right here, well, we know it's made up of this angle right here, and I know that angle is 72, and the reason why I know it's 72 because it's 36 plus 36 more. So it's actually sine of 72 equals x over 25. So I do 25 times sine of 72, and that gives me 23.78. 23.78. Add that 23.78 plus the 30 for the center height, and that tells me that C must be 53.78 feet high, which makes sense. And this is another thing that you need to do when you're solving questions like this, is that when I go back to the original page, remember how this was a height of 55? Well, if I go back to my answer here, this is slightly less than 55, which makes sense because if this was 55 and I got an answer of 57, I know I did something wrong because there's no way position C is higher than the highest point of the Ferris wheel. It's just barely less in height. So therefore, this makes sense. And I'm going to stop it right there. I know there's other examples. So for this example right here, you would basically do the exact same steps. Find the height of this triangle and this triangle, which is exactly what we just did. And then you can find the height of all the positions all the way around. Now, this one's a little bit different because it's got more sprockets. So 1, 2, 3, 4, 5, 6. So it must have 12 going all the way around. So 360 degrees divided by 12 tells you that each one of these pie pieces is 30 degrees, not 36 degrees like it was in the last question. So that's really the only difference here. So you're going to do sine of 30 degrees or sine of 60 degrees for this one right here. All right, thanks again for watching. Have a wonderful day, and